Okay, so yesterday you should have looked over some horizontal and vertical asymptotes and the rules for finding those and stuff like that. But today we need to talk about a different kind of asymptote on a graph. It is possible to have an asymptote that isn't horizontal or vertical, and that's going to be called a slant asymptote, or it could also be called an oblique asymptote. It literally just means that the asymptote goes across the graph and it's still a line, it's just not horizontal and it's not vertical, it's literally just slanted. So when this happens is going to be in the case that the numerator and denominator are in the form n plus 1 over n. And when I say the numerator and denominator, I'm talking about the exponents in the numerator and denominator. So yesterday, whenever we were talking about horizontal asymptotes, we looked at the fact that if you have big over little, talking about the exponents, then if the exponent in the numerator is higher than the exponent in the denominator, then there's no horizontal asymptote. Well, this with the n plus 1 over n is just a special case of that big over little. So if the highest exponent in the numerator is just 1 degree higher than the highest exponent in the denominator, that's when it's going to give us a slant asymptote. And then the way that you're going to find slant asymptotes is going to tie back into that polynomial division that we were looking at last week. So to find slant asymptotes, you have to use long division with polynomials. And then whatever your quotient is, that's going to be where the slant asymptote is. And then I also put in here, you're going to have to ignore the remainder. So we're just going to do this example right here at the bottom, where we have y equals x squared minus x over x plus 1. So we need to do long division on this. So we're going to have x squared minus x divided by x plus 1. So that first step in long division is you have to look at how many times your first term that you're dividing by goes into the first term on the inside. So how many times does x go into x squared? And another way of wording that is, what do you have to multiply x by to get x squared? And the answer to that is going to be just x. And so then you have to multiply the whole piece on the outside, the whole x plus 1, times that x and subtract it from what you have on the inside. So x times x is going to be x squared, and x times 1 is going to be x. And so that's what we're subtracting. So then x squared minus x squared is going to just be 0. That's going to cancel out. And then negative x minus x is going to be negative 2x. And so then you would say, how many times does that x that was back at the beginning, how many times does x go into negative 2x? And that is going to be negative 2 times. So then we need to multiply the negative 2 back by the x plus 1 piece. So negative 2 times x is going to be negative 2x, and then negative 2 times 1 is just going to be negative 2. And so you're subtracting out now the negative 2x minus 2 from just negative 2x. So the negative 2x and the minus negative 2x are going to cancel. And then we don't have just a constant term up here. So if you imagine that as just being like plus 0, then you'd be doing 0 minus negative 2, and then minus a negative is going to become a positive 2. And then since x can't go into just the 2, that 2 is going to be our remainder. And so then you don't have to worry about the remainder when you're doing long division for slant asymptotes. So since you don't have to worry about the remainder, this x minus 2 up here would be your whole answer. So if you wanted to find the slant asymptote, then you would have a slant asymptote at y equals x minus 2. and that would be your answer for that first example. So if you didn't get a chance to write it all down, or if you didn't pause it earlier, I would suggest going ahead and pausing now and getting these notes down, and then going on to the next example. Okay, so here's my next example. We need to divide x cubed by x squared minus 1. So the first thing that you're looking at is how many times does x squared go into x cubed? And the answer to that is just going to be 1x. And so then I need to multiply the x on the top that we just wrote times the x squared minus 1 on the outside and subtract it away from my inside portion. So I'm going to do minus x times x squared is just going to be x cubed, and x times negative 1 is negative x. And so then you're going to subtract that out. So x cubed minus x cubed is going to cancel, which is what we wanted. And then you don't have a term to subtract the x from. So just like in the last one, if you pretend like there was a 0 there, which you don't really have to, but if it helps you see it better, then you can write it in. Then it would be like 0x minus negative x, which is just going to be a positive x. And so then you're looking at how many times does x squared go into x, and it doesn't. So the remainder in this case is going to just be an x, which is kind of a weird remainder to have, but that's how it works out in this problem. And so then all we have on top is just an x. So the slant asymptote for x cubed over x squared minus 1 is just going to be y equals x. Okay, and then here is my last example, which I think is probably going to be a little bit more tricky than my ones before. But we have x cubed plus 2x squared plus 4, and it's going to be divided by 2x squared plus 1. So the first thing that I need to do is see how many times does 2x squared go into x cubed, which looks kind of weird because you're asking how many times a 2 goes into a 1. But what you're looking at is how many times do you have to multiply 2x squared to get x cubed. So you know there's going to be an x pretty much automatically. And then if you ask, what do you have to multiply the 2 by to get the 1x cubed, it's going to be just 1/2. I'm going to move that up so I can have room to write here. So I would have 1/2 x up there, if I can get it to look right. Okay, so 1/2 x. And so then I need to multiply my 1/2 x times this whole 2x squared plus 1 and subtract it out. So I'm going to do minus 1/2 x times 2x squared is just going to be our 1x cubed, which is what we want. And then 1/2 x times 1 is going to just be 1/2 x. And so then we need to actually subtract this out. So if I do my x cubed minus x cubed, those are going to cancel. And then I have 2x squared is the next thing that I need to bring down. And so I'm going to have my 2x squared. And then there wasn't anything to subtract from 2x squared in my little binomial right here, just because there wasn't an x term in what we were dividing by. So I just have to bring that 2x squared down anyway, and then I still am subtracting the 1/2 x. So 2x squared minus 1/2 x. And so then the next thing would be, how many times does 2x squared go into 2x squared? And the answer to that would be 1. If you multiply 2x squared by 1, you get 2x squared. So we need to add a 1 at the top here, and then we have to multiply that 1 by my whole thing, 2x squared plus 1, and subtract that out. So 1 times 2x squared is 2x squared, and 1 times 1 is 1. And so I need to subtract that away. So 2x squared minus 2x squared is going to cancel. And then we have negative 1/2 x minus 1. And so those can't combine, so it's just going to be negative 1/2 x minus 1. And then 2x squared cannot go into negative 1/2 x, so all of that. And then if I dragged down my plus 4 as well, then all of that, it would end up becoming negative 1/2 x plus 3, which that's not something that we would have to worry about that because all of that is just going to be a remainder. And again, remainders don't matter. Not in slant asymptotes anyway. So then our answer in this case is going to be the 1/2 x plus 1. So you would have a slant asymptote at y equals 1/2 x plus 1. And that's your answer. And so then just to kind of address this whole remainder situation and why we didn't have to worry about the 4 and all of that, once you hit a point where this first term in the thing that's in the denominator no longer goes into the first term on the inside, that's just when you stop, and then whatever you have on the top at that point is going to be your slant asymptote. If you wanted to find the legit remainder, then you would subtract it out and then pull down the 4 and do all of that. And so the remainder would have been negative 1/2 x plus 3, I believe. But you don't have to worry about that in this scenario. If you were just asked to do long division, then you would have to indicate what the remainder was. But when finding slant asymptotes, it doesn't matter. So that's why you can just stop at that point. So that's pretty much it for slant asymptotes. You're literally just going to make sure that the highest degree in the numerator is only 1 higher than the highest degree in the denominator to make sure that your function actually has a slant asymptote. And then once you see that it has the degrees lining up like that, then you can go ahead and do long division, and whatever line you get is going to be where your slant asymptote is. So if you have any questions about how to find these or about the process of long division or about asymptotes in general, just let me know. But that is all for slant asymptotes.